चलो ओके ना
time
what else does it have something to getting the maybe yeah sit down I will take out the book. The lights at night. Today, we have to start with the circle today, na? Yes. Hello. You did anything? No, sir. He didn't count anything. Sir, he didn't do anything. Same division. Yes, sir. And following pairs are coming. Yes. Sir, my time is the yeah, yeah. And then who is talking? What is the problem there? Now nobody will talk, no discussion, we can listen here. Yeah. Any doubts or difficulties in any questions? We practice only doubts will come out. Yeah. What item is it? Item is the doubt. What is the doubt? Really, each ambulance tell the question. Sir, I have also doubted. What is your doubt? First, third question. Three different models. You are speaking, you are planning. Okay. Yeah. Stop talking. Yeah. You didn't even follow what is that. I said radius of the circle is 3 centimeter, 15 centimeter. Then
and chord AB subtends an angle of 131 degree at the center.
131 degree at the center.
Yes.
Then
using trigonometry, calculate the length of AB.
Length of AB. There is a circle whose radius is equal to how much? 15 centimeter. And this angle is how much?
131 degree.
Okay, this is 15. You have to find out the length. There is one. If you draw the perpendicular from the center, bisects the chord. Okay, this is equal to 131 divided by 2. So 131 divided by 2 is how much? 65.5. Okay, this is which side? Perpendicular upon hypotenuse is equal to sine. Sine 65.5 is equal to AC upon OA. AB is equal, so OA you substitute. Therefore, convenient, no? He is standing there. AB is equal to 2AC. That is equal to 2 times OA will substitute 15 into sin. Okay, your problem solved. Why you are late? Traffic. Huh? Yeah. Okay now. Yeah, we follow.
Yes.
You can do it now. 65.1. You take the trigonometrical table and in the table you will see that value. Where is that need? Nowadays it doesn't come. Okay. Problem solved. Your trigonometry is over. Your trigonometry is over.
Yes.
Okay. What is your trigonometry problem? They are solving. You should read the question.
So tan A upon 1 minus cot A plus cot A upon 1 tan equal to sec A cos A plus 1.
Sec A plus sec A cos A plus 1. Tan A upon. See, talking and having fun only now. Yeah. Tan A upon 1 minus cot A. So tan A can be done sin A upon cos A divided by 1 minus cos A upon sin A. Plus next is cot A now.
Yes, sir.
Upon cot A is same as cos A upon sin A.
Upon 1 minus
1 minus sin A by cos A. Okay. Now, if you take this one, this LCM will what will get? Sin A minus cos A, and this will be sin A will go up to up. Therefore, it is sin square A divided by cos A times sin A minus cos A. This much is clear. Pratik,
yes, sir.
here also take the LCM and that cos A will go up cos square A upon sin A into cos A minus sin A. All right. You look, this is sin A minus cos A, this is cos A minus sin A.
Sir, we will change the sign.
Yes, change the Ishita standard. Continue doing. Standard there. Continue doing. You know everything, that's why you're sitting and talking now. Then first bench here, I'll make you to sit. Go to the other side. At least listen. No, I will not. I know everything. No. You are asking what? What you are asking? Let me also hear. About?
Yes.
Yeah. Okay. Now, look here, change the sign you followed. When you change the sign, it will come as minus will come. This will come as sin A minus cos A. Now you can take the LCM. So when you take the LCM, it will come. There is one sin A is there, one cos A is there, and the next one is what? Sin A minus cos A. And numerator will come, this sin A will be coming sin square A, that is sin cube A. Then minus cos cube A. Have you followed this page? Sin cube A. You have already this common enough, cos cube A. This is A cube minus B cube. A minus B will be cancelled. Then left out is A square sin square A plus cos square A plus AB sin A cos A upon sin A cos A. Have you followed?
Yes, sir.
Sin square A plus cos square A is 1. So 1 upon sin A cos A is sec A cos A. And sin A upon sin A.
Sir, I have a doubt. Why didn't
Series. Take it out and read it out. Yes.
Sir, why didn't you multiply sin A minus cos A?
Sin A minus cos A is the same denominator now, common denominator now. What is 1 by 5 plus 2 by 5 or 1 by 2 plus 5 by
6 by 2.
6 by 2. 6 by 2 now. So did you multiply 2 here? Common denominator, there is no need to multiply now. Otherwise, whole square has to write. Clear? So this one is 1 upon sin A cos A is sec A cos A. Tan, this is cancel plus cos. Okay. Done.
Yes, sir.
Huh?
Sir, I got one.
You got one. How did you get one?
Sir, I cancelled the sign.
So you can cancel. So we will cancel you. So 1 plus sin A cos A divided by sin A cos A. What is 1 plus x divided by x? X and x is cancel 1 now. No. The same thing you did now. These two cancel.
Yes, sir.
Possible? Mark is 0. You cannot now. It is not multiplication. It is multiplication.
So if we take common and if we cancel the.
There is nothing to common take now.
Sir, if there is.
If there is common, suppose it is coming
Then we can
here.
cancel with denominator.
X plus x square divided by x. What you can take? X is taken common. 1 plus x.
So if denominator is.
Oh, what is your number?
Sir, and one more y equal to y plus 1 by.
Why?
Two terms are like that. So what we will do. So means x plus x square upon x then plus 5 plus 5 square upon x. So we can cancel both x and y.
Plus y plus y square upon y.
Plus.
So from here x is taken common. Cancel. Left out is 1 plus x. From here y is taken constant. 1 plus y.
Okay, sir.
Then 1 plus 1 you can add and 2 plus x plus 1. Bring that bottle here. Yeah. Listen here. We are discussing the all of you close the volume. Close the volume. Take out the notebook. Take open a notebook. Yeah. Chapter circle part we are discussing. I'll tell you when to open the volume and its properties. That is, the basic part. That means, basic of the circle we will discuss. After that, we will go to the theorems of this 10th standard. Before going to the theorem of 10th standard, we have to learn around the 6 to 7 theorems of the 9th standard till 9th standard. Then only we are starting the theorem, because these all theorems we are using over here. Okay, last class you wrote what is the circle you wrote? Okay, circle is the set of all points in a plane which are equidistant from a fixed point. And the fixed point is called the center. Asim, what is fixed distance is called?
The radius.
From center, no? Last class you are arguing the fixed distance. Okay, what is the radius?
Fixed distance.
What is if the question is what is the radius of a circle, don't tell fixed distance. It is the distance between center and a point of the circle. Point at circumference. Now, what will be OP here? Radius of the circle. Okay. Now listen all of you. Done. Sign. Here. Over here. Where is P? Circumference. Where is O? Is it a point? Is it a point on the circle? No, it is point inside the circle. Circle means this curve only. Okay, circle meaning is this curve only, and beyond that, if it is circle, divide the plane into all time is there now? Don't worry. Okay. Now that also I'll go down and see. No? Okay. Circle divide the plane into 3 set of points. Points which are interior to the circle, points which are on the circle, points which are exterior to the circle. Suppose if I take Q, R, where is Q? Where is P? Where is R? Exterior surface. Okay, now how to identify whether Q is inside the circle or not? By looking.
Yes.
And if I say that
The distance between
distance between center and that point is less than the radius. Okay, understood. If distance between the center and that point is less than radius, that point is Inside. If it is distance between the point and the center is equal to the radius, is on the circle. And the third one, it is coming more than the radius. All of you follow? Now, so circle means this curve only. Do you know what is the meaning of circular region? Circular region. Ishita, circle will play. Read over here, listen over here. Circular region. Yes.
Area enclosement.
It is the circumference and the inside. Means on the circle and interior together is called the circular region. Now, that is the circular region is coming. What is the area of the circle? Circumference. All of you know what is the radius, isn't it? How many radius can be drawn? One. From any point, okay? It's all, you know. Do you know how to give the name of a circle? If you see this way, COR, circle whose center is O and radius equal to R. This is capital letter and this is small letter. Okay, that is called the circle name. Okay, next is, so one by one parts we are discussed. Now next is coming as one by one terms we are going to explain. These all things I don't think it's needed. Previous class yesterday. Chord. Spelling of chord. What is the chord? Those who know raise the hand. Those who know raise the hand. Yes. Fast.
Sir, it is the distance between the 2 points.
Line segment joining in 2 points.
Joining in 2 points.
2 points on circumference. How many chords can be drawn? In two. Infinite. After points are there now. Sit down. Line segment joining any 2 points. This line segment is called the chord of a circle. Okay? Yes or no? Yes. What happens? So, listen. Now we'll come to this. Now, here, chord you got infinite circle. Can a chord pass through the center? Yes, it is the largest chord diameter. What is the relation between diameter and radius? All of you know. Diameter is twice the radius. Okay. How about the radius? Is it a chord?
No, sir.
Radius is not a chord. Okay. Is it?
Sir, it is a fixed distance from the.
It's a fixed distance. Okay. It is not a chord that much. Okay. It's a line segment only. So chord of a circle, all of you followed. No problem. Okay. Now, next condition it is coming as. You know what is mean by an arc of a circle? Arc. Yeah.
Global definition.
Part of its circumference. Any part of continuous, listen here, what you could see, you just listen. Any part, continuous part of the circumference. Suppose if I take this one, AB. This part is called an arc. Okay, arc AB. This is an arc. Other part also is called an arc. How many types of arcs are there? Yes.
Sir, minor arc and major.
Minor arc and major arc. There are 3 types of arcs are there. One is minor arc, second one is major arc, third one is called semicircle. Listen. Consider 2 points in the circle. These 2 points divide the circle into 2 parts. The smaller one is called the minor arc, the other bigger one is called the major arc. Suppose if this point is diametrically opposite over here, both the arcs are equal, that is called semicircle. Okay,
Yes, sir.
minor arc, major arc, semicircle. Are you followed, all of you?
Yes, sir.
Semicircle, see, look here. Let's say see, if I join this one, this arc and this arc are equal now.
Yes.
Equal parts are equal part. What happened? Huh? Vertical. What do you mean by vertical and horizontal? Any line segment. You draw any which way. Okay. Yes. Now, so it is a followed now. Now listen carefully. Next is when I write this arc AB. Which arc is arc AB?
Minor.
KB means always minor R. If it is major R, you have to write major and RKB. Okay. Listen now. Listen. Okay. Now if I give the points RKCB, RADB.
Yes.
Here there is no need to write major. RKCB means, is it RKCB means it is always minor? Not necessary. Or is it always major? Depends upon. Okay, don't think that 3-letter means it's always major. Okay, here it is minor, here it is major. Understood all of you?
Yes, sir.
Minor R, major R. No problem. No problem. Okay, this is the condition which is coming as R. Okay. R of a circle. Minor R, major R. Next. Do you know what is meaning of? There are 3-4 words. One is congruent circles. Say equal radius. Congruent circle or equal circle. Listen, he is checking what all I'm teaching is correct. Okay, I will see. Don't take it. Okay. No problem. Do you know what is congruent circle? Same radius. It is also known as equal circle. Circles with the same center. Concentric circle. Okay, same center means concentric circle. The next 2 words I am going to do it. One is circumscribed circle.
Circle which is made inside and again.
Listen carefully. Those who know, please stop talking. Those who know, listen. Circumscribed circle. Akansha.
For a circle enclosing a figure.
Circle is inside or outside?
Outside.
Circle is outside the polygon. And the polygon is inside, and all the vertices are on the circle. Okay, if I draw this way, it is not necessarily quadrilateral. Okay, okay. This circle is called which one? Circumscribed circle. Circumscribed circle or even circumcircle. Circle outside. Vertices are on the circle. Okay, and this polygon is called cyclic quadrilateral. Listen, this polygon is called inscribed polygon. Listen here. I am revising for me now. You people know everything. If you know, I don't need to explain this all. This is called the inscribed polygon. Inscribed means inside. Circumscribed means outside. Next is called inscribed circle. Yes. Inscribed circle. Those who know, raise their hands. Yes.
Circle which is inside and same.
Not enough. Suppose if I draw, is it inscribed circle? It has to touch all the sides of the polygon. All the sides.
It is not
In this polygon, it is possible or not possible? How do you know?
Sir,
How do you know is it possible or not possible?
sir, the lower 2 sides
Lower 2 sides.
want to be touching.
Okay, tell me what is the meaning of inscribed circle?
Sir, a circle inside a polygon touching all its sides.
That's only I said no. Did I ask whether it's possible or not possible? How did you come to know it's not possible?
Sir,
Because there is no possibility. Okay, that we will for construction. I did not ask you now. Okay, just remember what is the meaning of inscribed circle? It is inside the polygon and it touches all the sides. Happy? You will see that there are sort of types of figures we can draw. If I draw this way, a circle is drawn. I make a small line segment. I make a big line segment. I make a small line segment. Possible? Now you see why it is possible, why not possible, you tell me. Huh? This length are same. Necessary or not? It's not necessary that all the sides are equal and all. There are cases not possible, are there? There are many people it's not possible. Okay. There are ways that are possible. Okay, now. Chalo, that is construction part comes in. So circumscribed, inscribed, yes, you have it out. So this also followed. What is the meaning of circumscribed, inscribed and all? Okay. Chord also followed all of you. Now, okay. Next one. So circle. Arc we discussed. How many types of arcs are there? Three arcs are there. Next is one more part I have to tell you. One. Close the. Actually, you are writing this one. Now, the next is, no need to write listen only. These are not just understand the concept. Next is sector of a circle. Those who know, please sector.
Sector enclosed by 2 radius.
Area enclosed by 2 radius and the respective arc. Not followed. Pizza. This shaded region called the sector. Non-shaded region, it is also sector. This is arc is minor means minor sector. Major sector. Okay, sector all of you followed.
Sir, 3 types of arc, major, minor, and
Semicircle. Okay, sector semicircle means it is semicircle. Okay. Next is segment of a circle. Segment. Segment of a circle. Remember, first tell.
Area enclosed by the chord and the arc.
Area enclosed between a chord and an arc. A chord divides the circle into 2 parts. Aritosh, you wanted to teach? I will sit over there. You wanted to give some idea? Okay, this shaded region is called the segment. Chord and an arc. Okay, even this region also is a segment. This is called minor segment and this is called the major segment. Okay now? All right. Now, next is coming again. I will come to the arc. I marked 2 points over here.
Yes.
Look, remove that mask and sit over there. Because you are talking over there. If anyone sees talking in there, remove the mask and sit over there. Yeah. Which is minor arc and which is major arc in this one? Both are equal, how do you know?
Sir, because it is on the scene.
Sir, because A is exactly parallel to.
A is a parallel. Listen here. Look, did I draw the diameter? Then, if I draw the diameter, how do you know it's passing through it?
So diameter. Yes.
Now, if I draw this way and if I take it as this one. Now tell me, which is minor segment and which is bigger and smaller, how to identify it? Where is the center is there, that is called the major arc. Where is the center? Inside this. That is called the major arc. Where center is not there, that is called the minor arc. Identify. Understood? You generally these all things you can identify. If you are unable to get me, join them. Center lie in the major arc. Okay, other one is minor arc. Okay, clarified. If it is doubt, rejoin the line segment AB. Where is the center? The upper part, no. The upper is major arc. This one is minor arc. Okay, because you know it will be the center part will have a more part. Yes, what is your problem?
Sir, what is the center line on the?
Then it is called the semicircle. Equal division, no? If I go, suppose if this was the way, then both are equal. Then it is called which one? Semicircle.
Achha, okay,
Understood now? Okay.
Sir, I was confused because
Close the textbook first. That is then your problem is.
sir, because AOB are joining.
Now listen. Now listen here. Now I'm going to talk about the next one. It is coming as a measure of an arc or angle subtended by an arc at the center. This is an important part over here. Most of the places we are going to do this property. Property means this one. Consider the RKB. Angle AOB is the angle subtended by RKB at the center. I repeat, angle AOB is the angle subtended by RKB at the center. Are you followed? If it is coming as, let's say, B and C, what will be the angle subtended by RBC at the center? BOC. Okay, if I take D, what is the angle subtended at the center? Angle COD. Okay, angle COD, this is the angle subtended by the arc at the center. This is also known as the measure of the arc. Okay, angle subtended by arc at the center. Now, next is when you consider RKB, this is which arc now? Minor. Other part is major arc. So what will be the angle subtended by the major arc at the center? Reflex angle. This angle is called reflex angle. Minor subtended by the major arc AB at the center is reflex angle AOB. Angle subtended by arc AB or minor arc means angle AOB. The other part is this one. Okay, reflex angle. You know how to find out the reflex angle. What do you mean by reflex angle? Which is more than 180 less than 360. Okay, 360 minus this angle is called the reflex angle. Understood all of you?
Yes, sir.
So angle subtended by an arc is, it is coming as angle at the center. Major arc means reflex angle or 360 minus the corresponding minor arc. What is the angle subtended by the semicircle at the center?
180.
Semicircle at the center, 180, because the straight line it will come now.
Yes.
This angle is how much? 180. One complete full rotation means how much? 360. So this is equal to 180 degrees. So you got it all the three cases. Angle subtended by the minor arc is the central angle. Angle subtended by the major arc, reflex angle. Angle subtended by the semicircle, 180 degrees at the center. Okay. Now, next is. Any problem? If you consider the minor arc AB, the remaining part is this major arc AB is called the remaining part of the circumference. Okay. Whenever we consider minor arc AB, this the other remaining part of the circumference is major arc AB. If I join this one, angle ACB is the angle subtended by RKB where at a point in the remaining part of the circumference. I repeat, angle ACB is the angle subtended by RKB at a point where in the remaining part of the circumference. You check this is RKB, the remaining part. Suppose if I take D, what is angle ADB? Angle subtended by the RKB in the remaining part of the circumference. Angle AEB. RKB. Where is it? It is not in the remaining part. No, center is on. It is in the inside, interior. It is E is not on the circle now. If it E is only, then only circumference. AFB. What is AFB? Angle subtended by R, an exterior point. It is interior point. This is center point. This is the remaining part. Are you following all the conditions? Okay. Angle subtended by minor arc, major arc. Okay, all these conditions are you following? Okay, remaining part of the circumference. So finally, if I take, let's say ARB. Can you tell a name for angle ARB? Angle subtended by
The RKB,
which arm? Major arc AB in the remaining part of the circumference. Let's come to these three. What is angle AOB? Angle separated by RKB at the center. What is the reflex angle AOB? What is reflex angle A? Angle subtended by which are? Major arc at the center. Okay. What is the angle ACB? Angle subtended by AB in the remaining part of the subtended. What is the angle ADB? Angle subtended by the major arc in the remaining part. Follow all the cases. Okay.
So we can write this case.
AOB is once again, I'll tell. So because you know these all one by one writing, it will take a lot of time for you. Angle AOB is the angle subtended by which are RKB at where center. What is angle ACB? Angle subtended by which are RKB. The remaining part of the subtended. At that point remaining. Next is reflex angle AOB. Angle subtended by which are major RKB at the center. Angle ADB. Angle subtended by major RKB, the remaining part of the subtended. Follow this one?
Yes, sir.
Okay, interior, exterior, later we will discuss. So just clear all of you?
Yes, sir.
So these are the conditions will come of basic concepts are coming. Now I am going to give you all the previous theorems. Last year you have done us. Okay, I will give all the theorems. Whichever you have doubt, with the help of the figure, I will explain. Okay. For football, what happened? Huh? So football is also circle, no, goal. That is the problem. No? So, right. Chapter 18 circle because of circle only, if it is penny, imagine there is a football match going on. Then that will not win. No? Who is your favorite team? Huh? Here it's a World Cup is coming, you know, our favorite team. Okay. Yeah. Right, right. Previous theorems. Okay. First one. Theorem 1. Perpendicular 1. Perpendicular drawn from the center. Perpendicular from the center. Short form actually, no need of in detail alone. Bisects the chord. Perpendicular from the center. Bisects the chord. Okay. Theorem 2.
Sir, wait a second.
Written perpendicular from the center bisects the chord. Theorem 2. Line from the center which bisects the chord. Line from the center which bisects the chord is perpendicular. Line drawn from the center which bisects the chord is perpendicular. Written theorem 2. Yes. Theorem 3. Equal chords subtend equal angles at the center. Equal chords subtend SUBE and E and D subtends equal angles at the center. Okay. 4. Theorem 4. Chords which subtend equal angles at the center. Chords which subtend equal angles at the center are equal.
So can you just say converse of 3?
Chords which subtend equal angles at the center are equal. Equal angle at the center are equal. Chords which subtend equal angles at the center are equal. Written. Next. 4 you wrote now.
Yes, sir.
5. Equal chords are equidistant from the center. Equal chords are equidistant from the center. Equal chords are equidistant from the center. Theorem 6. Chords which are equidistant from the center are equal. Chords which are equidistant from the center are equal. Chords which are equidistant from the center are equal. 7. There is one and only one circle.
There is already in one.
There is one and only one circle passing through. There is one and only one circle passing through 3 non-collinear points. 3 non-collinear points. One and only one circle passing through 3 non-collinear points. These are the main theorems previous year. There are 2 properties are there. I'll understand. Okay. How write the property? Perpendicular bisector of a chord passes through the center. Perpendicular bisector.
Sir, next point.
Next.
Or theorem 7.
Theorem or a property, right? Perpendicular bisector of a chord passes through the center. Right? Perpendicular bisector of a chord passes through the center. Then, and the
Passes
next
through the
center. And next one, no need to write perpendicular where the perpendicular bisectors of the chord intersect at the center. Isn't it? Passing everyone passes through the meet at the center. Okay. Listen, one by one. Whichever the problems not followed, raise a hand. I will explain. First one not followed.
No, sir, theorem 7.
One by one. Theorem 1. Anyone having a problem? If you have a problem, I will draw the figure and explain. No problem. Theorem 2. No problem. Theorem 3.
Sir, can you explain the second? Second.
Read the second one.
Line from the center which bisects the chord is perpendicular.
Do you know what you mean by bisects? What do you mean by bisects?
That divides into 2.
I am asking you. Bisects mean
Divides
into 2 equal parts. Line from the center which bisects the chord. If this satisfies means automatically OC will be perpendicular to AB. If C is the midpoint of AB, then OC will be perpendicular. That is the converse of the first theorem. Perpendicular. If it is perpendicular, then it bisects. And the property just now you wrote, always perpendicular bisector passes through the center of the circle. Okay, ma'am?
Yes, sir.
Okay. Theorem 1, 2, 3, any problem? Third one. What is the theorem?
equal chords subtend equal angles.
Equal chords subtend equal angles at the center. Consider AB and CD. If they are equal, they subtend equal angles at the center. Are you followed?
Yes.
Means whenever AB and CD are equal, angle AOB will be equal to angle COD. When AB is equal to CD, they subtend equal angles at the center. Means angle AOB will be equal to angle COD. Okay, that is the third one. Fourth one, any problem?
Yes.
Converse, when angle AOB is equal to angle COD, then AB equal to CD. Okay. Fifth one is equal chords are equidistant from the center. Do you know what is the meaning of what is the distance between a point and a line? What is the distance between the point and the line? Perpendicular distance. Find the distance between O and L means what you have to do, draw the perpendicular. This is the distance. There are a lot of ways we can join, this way of joining. But which is the distance? Perpendicular. Perpendicular. Are you followed, all of you?
Yes, sir.
Okay, perpendicular. So that is why, again, equal chords. If I draw the perpendicular, this should be equal. It's all both will be equal. Okay, on 6 to next come goes. Okay, what is it? If the distances are equal, whatever. Okay, so distances are equal, chords are equal. Okay, next one, 7th one. Doubts?
Yes, sir.
There are 4, 5. Okay,
Yes, sir.
okay, one and only one circle passing through how many points? 3 non-convenient points. What's the point? Before going to that one. If you consider a single point, how many circles pass through this point? Infinite circle. That means there is no problem. You can draw a lot of circles passing through this point. Not this as center. Okay. Consider 2 different points. How many circles pass through these 2 different points? 1, 2, 3, 4. 1, 2, 3, 4. 1,
Infinite, sir.
1. Those who feel 1, raise the hand. Majority is in 2, raise the hand. Or 2. There are 2 raise the hand means 3, 4, infinite. Yes. Okay, infinite man explain how did you do infinite. Okay, 4 circles explain. Forget about infinite. Because there are people who say can you draw? Okay, draw. Well, explain here to me how it is coming.
Yes.
What is that? Yes, circle. That's a ellipse. Oh, listen here. All of you listen. We joined AB. Line segment AB. You know how to draw its perpendicular bisector?
Yes, sir.
All of you know perpendicular bisector now?
Yes, sir. 61, 29.
Okay, perpendicular bisector. Perpendicular bisector is not 61 29. That is 90-degree drawing. How do you draw perpendicular bisector? Raise the hand.
Sir, from A1 arc and B1 arc.
More than half. That is 60-90 is 90-degree drawing now. Okay now. Consider a point, let's say P. How about PA and BB? PA and BB equal. Agreed or not?
Yes, sir.
PA and BB will be equal now. Triangle will be congruent now. So, okay, with P as center, radius equal to PA. If you draw a circle, where does it pass through PB? Where does it pass through B? With the P as center, radius is equal to PA. If you draw a circle, will it pass through the point B?
Yes, sir. The P and BB would be. Yes, sir.
Right.
Oh, sir, it will be over.
Equator. The overlapping just study amount. With Q, hello. Listen. With QA and QB are equal.
Yes,
No.
sir.
Somebody.
Yes, sir.
QA and QB are equal.
Yes, sir.
With Q as center, radius equal to QA. If you draw the circle, will it pass through B?
Yes, sir.
Yes. Ah,
Sir, not able to understand what you are telling that it will pass.
will it pass through A and B? Yes or no? Answer to my question. Is it PA and PB are equal?
Yes.
So you take P as center and radius is equal to PA. Draw the circle. Will it pass through A and B? PA and PB are equal means it should pass both are radius now. Same way QA and QB equal means both are radius now. RA and RB equal means, so how many circles you draw? All these 3 circles pass through where? A and B. So in this line, how many points are there? Infinite. Their answer is infinite. Okay. Understood? How many circles can be passing through A and B? This is the way to explain. Okay. Take any point on the perpendicular. Overlapping in coinciding column. Ah. Okay. Understood?
Yes, sir.
So any point on the perpendicular bisector take, then you draw the circle with that point as center and radius is equal distance to that point. This is the property which is there in your locus. That chapter is not there. Okay. Please follow.
Sir, college.
Who's good? Chalo, okay now. So hold on now. Now next one. Listen. A, B, C. How many circles pass through these 3 points? Who said that in fact? Look here. First of all, what does it look like ABC? Collinear or not? You know what is the meaning of collinear? Right at the same time. Can you draw a circle passing through all the 3 points? You cannot. Reason. Points on the circle are always non-collinear. If you draw a line, at how many points a circle can meet? Only 2 points, maximum 2 points only, no? Can you draw a line which meet the circle in 3 points? No. No. That's so points on the circle are always non-collinear. So there is no circle pass through these points. If the 3 points are non-collinear, who's the again infinite? Who is this infinite man? You know what is the meaning of infinite? Okay. Okay. Array, we will break into pieces of pizza. When one basket you need to carry it. Okay. Now, if there are 3 non-collinear points, there always you can draw a circle, and there is only one circle. That circumscribed circle now. Yes, sir. This if I join, there is a triangle will come now. Circumscribed circle will come. So when 3 non-collinear points, how many circle? One. That construction is there in your construction chapter. I'll explain that circumscribed. Okay, that is so. These all properties are clear. Yes, sir. No problem. Okay. So points on the circle are non-collinear. Points on the circle are non-collinear. Yes, or no? Or collinear? No. Okay. Even a line which intersect, at how many points a line can be intersect? 2. At 2 points only. Can you draw a line more than 2 points? No. Okay. These all properties are clear. Any of the property if you are not followed, tell me, Alex. Jambavi, you want to add up something? Okay, please add. You are shouting at her. Why are you shouting at her? Ishita is there. How are you? Please stand up. Okay. Ishita, lot of theorems are written now. Not to look at that. Can you tell any one theorem from them? Without seeing. Anyone. You're not. I don't look in the book, I said. What which are equation from the center are equal. So I should propose only one and only one. You cannot. Anyone here? Perpendicular drawn from the center to the front bisex is called. So you are copying from what? It's at the same. All the which are equation from the center are equal. Can you tell another one? Engagement. Equal chord subtend equal angles at the center. That's the nickel. Can you tell one property? No. And make it stand on the bench now. You stand on the See, I will answer. Everyone will face the hand. You want to see one property and many others. You could have offered one, you could have learned. There is not even one sentence, half sentence only. You will stand over there and learn. Well, what is it? Tell. Even you have the headache, still you learn. I got a problem. Okay. Huh? Learn, don't look at the look here, tell me. Otherwise, I'll not give break for everyone. Ignore. Long time I have no need. Okay. Yeah. Tell one me. From the center or from the equal. Sit down. Then tell me. Ready? No. Yeah. Naira, give me one here. One here. Find the body. Perpendicular. Kneel. Tell what the other. One more. I think you three once again then. From the very good. Very good.